we do it Wednesday? Would that be all right?
Yeah, that would be fine.
Okay.
All right, guys. Moving along, second unit, using arrays. I hope y'all have hit the idea of arrays before. I hope we don't have to, spend a month on this idea. In Python, they were called lists. A list is actually not an array because a list can grow and shrink. And an array, once declared, stays of that size. And if you've done C++ programming or Java programming, you're familiar with that concept. And there's a different data structure that you use if you need something that'll grow and shrink. And what does that mean? Say you have an apartment complex and it's got 100 buildings, right? You could consider that an array. A different person's going to move into each apartment. And, when you build the apartment, it's empty, but there's still 100 places for people. And then when people start moving in, you put one in the first apartment, one in the second, and you can fill it up. But once you fill it up, tough. You filled all 100 apartments. You can't just go and add one on. Yeah, in the real world, maybe you can build a new wing or something like that, right? But once you hit the end of the array, you're out of luck unless you're going to allocate a new array and then copy all the data in. So that's like building a brand new apartment complex with 200 apartments, moving all the people in so that you can then add that new person and then tearing down the old one, right? And so that's kind of memory intensive. So as soon as we can get away from using arrays and using another data structure, the better off we are. But on the other hand, arrays are the fastest possible way of storing and accessing a list of data because the data is stored contiguously in memory. Whereas if you have something like an array list, if you have anything else, like a Python list or any other kind of list, then when it is being traversed, then it's jumping all through memory using something known as a linked list. And so, in order to go from the first element to the second one, it has to do a couple of lookups, and it's not just already stored in memory because it was guaranteed to be contiguous as it is with an array. So what are we going to talk about? Declaring an array, assigning values to array elements, accessing them, search an array using a loop, using binary search, sort, and reverse, using multi-dimensional arrays, and learn about array issues in graphical user interface programs. Now, declaring an array is going to be awfully similar for you C++ and you Java programmers, not for you Python programmers. So what is an array? Now, we're going to use the word list. I don't know if that's the right term because, as I've just said, a list implies something else. A list is something that grows or shrinks as you add data to it. Anyway, it's a series, a list of data items that have the same data type and the same name, right? So if you declare an array of type doubles, you can't suddenly start storing strings in the middle of it. And that's not true of Python, where you could create a list and then you could add data of any sort to it. Once you declare your array, you're restricted to that type. Now, yeah, you can stick ints into a double, right, because ints get converted cleanly into a double pretty much. But anyways, here's how you declare and create an array. And so the idea of them having the same name is like, say you were going to create a program. You were going to make, a 6-sided die, and you were going to roll it 1,000 times, and you wanted to count, the number of times that it rolled a 1, and the number of times it rolled a number 2, and so on. So your code might look like this. You might declare, 6 different die counters. That's the number of times that it rolled a 1, and a 2, and a 3, and a 4, and a 5, and a 6, and then we need to initialize them all, right, to 0. And so then we'd have some kind of loop in here. Whatever, while, whatever, and then it's adding into these variables somehow, right? If the die roll was equal to a 1, then we add 1, to 1. If the die roll was equal to a 2, then we add 1 to D2, right? And so on. And then by the time this loop is done, then we have these 6 variables with these counters, and each one contains, the number of times a 1 was rolled and the number of 2. And so if you want to add them up, right, you can do this. Total is equal to, D1 plus D2 plus D3, and so on. But it's nicer if they're in a list, if you can just use the same variable name. Well, why is that? Well, what if you decide to increase the size of the random numbers you're generating. You're no longer just generating numbers between 1 and 6, you're generating numbers between 1 and 10,000, right? Which is perfectly acceptable to do. Well, what are you going to do? Are you going to create 10,000 different D variables and you're going to initialize them all to 0 and you're going to have 10,000 if statements? No, you're not going to want to do that. Instead, you're going to want a variable that all has the same name, but then each element is addressable separately, just like an apartment, right? You live in Whitehurst Apartments, but you live in room 1, apartment 1, or apartment 2, or apartment 3. Each person is identified by their apartment number, which we will call the index number or the subscript. So when we declare our array, we do it like this. Sales is equal to new double subscript 20. Square braces 20, not parentheses. And that says, I need a space in memory to hold 20 doubles. And then we can access them individually. So we could go in and we could declare our array, and we could say the sales for month 1. Okay, why did I put a 0 there? Because 0-based indexing, the first element is index 0, the second element is index 1, and so on. We've hit that idea before. So, you earned 10,000, you sold that many in that day, you sold that, that many in that day or that month, whatever, and so on. And then for some reason you didn't have any sales at all, so that was left at 0, and then sales 5, is, I skipped sales 2. Let me go and copy and paste that. Okay, so, all right, so we have 6 different pieces of data here, all sharing the same name, differentiated by their index number, by their subscript. Notice that we can go from 0 up to 5, if that was 6. I'm going to change that to a 6, right, just to match my example, because I don't feel like typing, 20 different values. So, since this is 6, since it has a length of 6, we can access elements 0 through 5. If we try to access any value larger than 5, it's an error. Can't get up larger than 5. Why? Because then we would be accessing the 7th element, and we only have 6. So, hopefully you're already used to the idea of 0-based indexing, where if you declare something of size 10, you can go from 0 to 9. Or if you declare something of size 100, you can go from 0 to 99. The techie computer way of saying it is that you can go from 0 to n minus 1, where n equals the length, right? This says you can change the size of an array. Now, I made a great big lecture about how you couldn't change the size of the array, so I may be forgetting something that I'm going to see on the next slide. Alrighty, so an array element. Each object in an array is called an element. And the subscript, also known as the index, is the position. So the first element is stored in index 0. The second element is stored in index 1, just like apartment numbers. Remember to start counting at 0. And so here is some sales. We're going from sales 0 to sales 19, just like their example. And if we look at the memory address, the memory addresses, which you don't care about, show that each one is 8 bytes apart. Why? Because each one of these is a double, and a double is an 8-byte data type. So when you ask the computer for sales subscript 0, it goes to that memory address. But then when you want sales subscript 1, it goes to this memory address plus 8. 2,000 plus 1 times 8. And if you go to index 2, it goes to 2,000 plus 2 times 8. Right, so that's a very fast way of indexing values. Or excuse me, that's a exceptionally good way of storing the data so that they can be accessed quickly. So in C#, arrays are objects. Arrays are instances of a class named system array. It's kind of similar to Java. They're still supposed to be stored contiguously in memory, like we saw that. But there's a class around them as well. And why is that? Because it's nice to be able to query the class, the array, and find out how long it is. And if it's just a pure, simple data type, as it is in C++, you can't ask the array for the length. You have to do some calculations, or you've got to store it beforehand as a constant, something like that. So numeric fields are all initialized to 0. Character fields are all initialized to /U0, which is just another form of 0. And Boolean fields are all set to false, which is another form of 0, right? So when you create an array, all the values are initially set to 0. So when I did this, if I printed out sales subscript 0, it would print 0. And then if I did sales subscript 1, it would also be 0. And then if I did sales subscript 2, I could write a loop that would iterate through them and print them all. Because they have been nicely initialized to 0. And that's a difference from C++, where your data was not necessarily clean when you allocated it. They were not necessarily initialized to 0. Now you could force that, but by default they were not. You can use an initializer list, which is a list of values provided for the array. C++ and Java guys will recognize this. Python folks will remember a variation of that. Now this is not the syntax for it. Yeah, it is. All right. It's different than Java. In Java, I'm not going to even talk about that. Anyways, you had an equal sign like that, right? And it said equal, and it had a list of values between the curly braces. And C++ was the same way. And if you recall, in Python, you had square braces to denote your list. But this is C#. Syntax is going to be a little bit different. What you got to do is the first part of the syntax is the same. You say, I want an array of ints. I want it to be stored in that variable name. I'm going to have to create it, so I use the new keyword. And then I specify the size of it. And then, oh, by the way, if I put some curly braces after that, it will initialize it with those 5 values. So by the time we're done with this, oh, that's the syntax I'm looking for, this third one. By the time you're done with this, the first value will be set to 100. The second value will be set to 76. The third one will be set to 88, and so on. Now this syntax, that's kind of for the birds, maybe, if you can just do this, right? That's really how we want to do it. If you say, I want an array of ints, here's the name of them, and go ahead and initialize them with these values, the compiler will go, oh, you need 5. And so it'll go ahead and do the new int 5 for you. Much better syntax. So if you declare a size, you must list a value for each element. So if I do 5, I'd better have 5 elements here. And that's different from C++, where you could get away with just storing one number in the first value and the rest of them would be formatted to 0. If you initialize an array with values, you're not required to give a length, which is example 2. And if you're going to do that, you don't even need the new keyword. The power of arrays becomes apparent when you use subscripts that are variables rather than constant values. Arrays and loops go hand in hand, right? Here we have a variable called sub for subscript, right? And we're going to count from 0 to 1 less than 5 because it's an array of length 5. And we're going to add some value to that specific slot in the array. Here's the same thing expressed as a while loop, right? So the first thing that's going to happen is array subscript 0 because we initialized it to 0. We'll have 3 added to it. And then the position 1, once we increment sub, we'll have 3 added to it. And then this will become a 2, and we'll add 3 to it. And then this will become a 3, we'll add 2 to it, 3 to it. This will become a 4, we'll add 3 to it. And then this will become a 5. Well, that was our terminating condition, so nothing happens past that point. So pretty much arrays and loops go hand in hand. Almost every time you use an array, in my opinion, you're going to wind up using a loop of some kind. So the length property. This is nice. C++ doesn't give you this. When you create an array, a property in that class is set to the length of the array. You declare an array of 20, then you'll be able to ask for the dot length, like this, and it'll tell you that it's 20. That's good. That's good for looping. right? So that your for loop can look like this. For x is equals 0, x is less than my scores dot length. That way it knows to keep going, up until, that n minus 1 that I mentioned, right? 1 less than the length. And then add x to it. And we're going to give some examples in the code as well. Using for each. Maybe you remember in Python you could do this. For x in L, where L was a list. Very similar syntax. For each int x in L, if L is an array of int, right? Do some stuff. Same exact idea. You can do that. And your Java folks will remember it like this. For int x colon L. Right. Similar syntax, same exact idea. When C# was being copied from the Java language, they added the for each keyword, and I love it. I love having that keyword there. So, if you do that, for each, what did we declare our sales as? We declared sales as doubles. So if we want to print them all out, for each, or add them all up, the sum is equal to 0. And then for each double, and I like V for value. You could also use E for element. For every element in sales, right, add that to sum. Sum equals sum plus E, or sum plus equals E, right? So E gets the first value in the array, it gets the second value, it gets the third, it gets the fourth, it gets the fifth value in the array, except I should have started counting at 0, and it gets the sixth value of the array. So it gets 0 through 5 sequentially. And we don't have to access it via an index. If we did want to access it via an index, the loop looks a little bit different. Double sum is equal to 0. For int I is a good index. I is less than the length of sales. So I should do, get it out using the array, the length property. Each time, add 1 to I. And I'm going to modify this just a little bit. Double E is equal to the sum, sales subscript I, and then add sum, add that to sum. Now, could I have just done this here? Did I have to create a temporary variable? I could have just done that. There's a reason I did that, though, because these two are exactly equivalent at this point. You see, the sales at that specific index is being copied into E and then added to sum, just like this. That particular index value, that particular element is being copied into E so that it can be added to sum. So this is a summation loop using for each. And this is a summation loop using for, and I'm going to call it for index. And again, we could have just taken this, pasted it there, and delete that line, right? Would have worked just as well. Would have been cleaner. There's no reason to do that copy. I just did it to show the equivalency, the exact equivalency of the two things. So here we have a series called pay rates. And we want to print out all the pay rates. So we're going to use a for each loop for every money value and pay rate. We're going to print out the money.toString formatted to be a C currency value. So that will print it out. It'll print out 600, on one line, print out 7.35 on another, 8.12 on a third, and so on. So using for each. The iteration variable is read only. If you guys dug deep into C++, you may remember that you were able to declare the iteration variable as a reference, and at that point it was not read only. But in Java and in C#, the iteration variable is read only. You can access it, but you cannot assign a value to it. Remember this loop up here where we were adding 3 to every value in it, like that? every element in the array was being increased by 3. With a for each loop, you can't do that. You can't change it. Why? Because it's just a copy, right? E gets a copy of sales, and then yeah, if we did E++, big deal. It didn't change sales. Same thing's going on up here. E just gets a copy of the value. And so if you make any changes to it, it wouldn't affect it because, it's a copy of what's in sales. This is effectively giving, like a sheet, like it's making a photocopy of a book, and each page is being, photocopied and then handed to us in order for us to use. We don't get to access the original book. We're getting a copy of each page in turn. We're getting a copy of every element in turn. So the iteration variable is read-only. So you can access it, but you cannot assign a value to it. So this would be an error if I tried to do this. If I tried to do E equals, 7 for some stupid reason, right? I want to set every value to 7 as we go through the loop. Can't do that. E is a read-only variable because it's the iterator and a for each. Take that out. So searching an array using a loop. You can search for an element by hand, right? You could use an index-based for loop, and you could check every element in turn, and when you found it, great. So this is called a sequential search. I'm going to take this stuff and paste it in my own code because that kind of clutters it. Now that's kind of dumb. All right. Say you're looking for the index number. You have an array called names. I don't care how we declared it, right? But it's got several values in it. Jeff, Joe, and Jill. Okay, fine. String names is equal to Jeff, Joe, and Jill. Now we're going to search that array for Joe. We want the index number. So what I would do is I would create a variable to hold the index value, but I would initialize it to -1. And if it remains -1 by the time we go through the loop, it means it was never found. So I'm going to call that found at. I'm going to initialize it to -1, and that's a special value that indicates that our loop didn't find anything. And then I would use a index-based loop. For int I equals 0, I is less than the length of the array. I'm going to hard code that 3 to be lazy. And then ++ I. All right, and then we would check. If names subscript I is equal to Joe, we need our cute little parentheses and all that, then found at equals that index. Then after our loop, if the found at still equals -1, then we didn't find it. Else, we have the index value. Now use it. That's a sequential search. We just start at the array, we go to the end of the array. I want to get the correct syntax for getting the length of it. So, excuse me for stepping back. I want to make sure I get it exactly correct. All right, so it's just the array name followed by .length, but .length is in uppercase L. And it's not a function call, it's just a property, so you don't use any parentheses. So to do this correctly, I is equal to 0, I is less than names.length, like that. And then I++. So that's a sequential search. And you can bet that there is a sequential search method built into the language because it's such a common thing to do. Now, is it the fastest way to search for an element? Not necessarily. If the elements happen to be arranged in order, Like if these were alphabetically arranged in order, you can do what's known as a binary search. Just like a guessing game, right? I'm thinking of a number between 1 and 100, and so in my head I pick 73, right? And you guess. Well, you usually start at the middle if you're going to be smart about it. You guess 50, and I go, nope, it's larger. And then you go, okay, well, between 50 and 100, I'm going to pick the middle of that, 75. And I say, nope, smaller. And then you pick a number between 75 and 51, whatever, 62 or something like that, and you zero in on it. And it's a far faster way of doing it than a sequential search, where you just, because a sequential search, what if this array was 1,000 elements long? If it didn't find it, you would have to search 1,000 elements to determine it wasn't there. A sequential search can figure that out in 10 moves or something like that. We could optimize this code a little bit so that when it finds it, it immediately bails, right? Because if we found it, we don't need to keep checking. So we could put a break statement here. You put a break statement to indicate, as soon as we found that, indicating that we found the index of the array that matches our target, Joe, then we don't need to keep looking. So we'll just break. This optimizes it. But still, on average, if it's 1,000 long, it's going to take an average of 500 peeks into the array to find the element, right? And worst case is it's going to have to check all 1,000 of them. Best case is it finds it in the first one or whatever. But the worst case, if it's 1,000 elements long, let me see if I remember, what's the log of 1,000? Log 2 of 1,000. Something like that. Okay, so I'm correct. It would take 10, at most 10 searches to either rule it out or find it. Still ideally, if it's in the middle, you get it, on the first try. But at most 10, rather than at most 1,000. So, a binary search is far better than a sequential search. However, there's the drawback that it has to be sorted. And keeping things sorted takes time, especially if you're doing an array. If you're using an array, you can't just... Anyways, okay. So using a for loop or using a while loop. It's called a sequential search. And their code here is almost meaningless. I like mine a lot better. It is checking to see if it's a valid order number, right? That's all this is doing, is it's checking the array, and if it finds an element that matches our target value, then it sets a variable, a flag, to true. Okay. That's called a sequential search because each array element is examined in sequence. Now, a parallel array is a second array that's of the same length. That's critical. That allows you to use the same subscript to access additional information. Like, how about first names and last names? String, I had names up here, right? I had 3 names. That's one array. And then I'm going to make an L names, or last names variable. And just last name is Thompson. Joe's last name is Roberts. And Jill's last name is Smith. Like that. So if you want to print out somebody's first name and last name, string full name. Full name equals names subscript 0 plus a space plus last names subscript 0. And then print that out, right? Or use a loop. Name 1, full name 1 is that. And then full name 2 is when the index are set to 1, and full name 3 is when the index values are set to 2. Right, so they match up, they hook up. They are linked by their index number. So my informal definition of parallel arrays is when you have 2 or more arrays of the same length where the data elements are conceptually linked by their index number. Right, the index number 0 identifies Jeff Thompson. Index number 1 identifies Joe Roberts, and index 2 identifies Jill Smith. want to go ahead and look at our lecture notes, our short lecture notes. I believe there's something coming up in them. If I can find them. Should be under short, or should be in lecture L. And by the way, I hope everybody approves of the way these have been redone, right? To where the two lectures, the assignments that follow a lecture are kind of tucked away and in it underneath it. Well, anyways, we're going to go down to L. I'm not in student mode, but you should see an attachment. Short 7.zip. That's back when I numbered my attachments. I should rename that to lecture L.zip. I'll maybe re-upload that. I'll do it now. Alright, so I'm going to download the zip file. It's got a program file in it that I want. You could open the whole project, or you could just copy and paste the .cs file into a new file. It's just a console application. So I opened it, whatever you want to do. I'm just going to grab the contents of program.cs. Oh, little boy, it's a little teeny tiny. So I'm going to copy it all. Copy everything. Actually, I'm just going to copy everything inside main. I don't need anything else. So I'm going to take the main from static void main all the way down to in main, and then I'm going to go into Visual Studio and make a new project, new solution, so to speak. All right, so new file, new project. And I know you know how to do this, but I'm going to talk it through anyways. We want C#, Windows Desktop, Console Application, Lecture L. And there it is, and I'm going to replace the main that's in my lecture here. Excuse me, inside my class. With that one. All right, well that expanded a lot. There's a lot of stuff here. It's got these regions here, right? I've already shown y'all regions. I'm going to minimize all the regions to try to make sense out of all this stuff. All right, so notice up here, we have an array full of days, right? It's using an initializer to fill an array called days, and it's got, you know, Monday, Tuesday, Wednesday, Thursday, Friday, so it's of length 5. And then we create a parallel array. I'm going to go ahead and mention that. Parallel arrays, days versus temperatures. All right, gather our input. So, this is just a for loop using an index. And what we want to do is say, please enter the temperature for Monday. Please enter the temperature for Tuesday. Please enter the temperature for Wednesday. So for each index number, x is equal to 0, so on, we want to print out that day, and we want to store something in to that equivalent element, that parallel element in the temperatures array. All right, this is doing a do while loop. Using a do loop to make sure that we get good valid input out of it. So anyways, modify the console right below to prompt the user for the input in the form of please enter the water sample temperature for XXX, where XXX is the day of the week. And we're going to fill that in. Maybe I'll make it a right line, because that's a pretty long prompt. Yeah, I don't know. I'll just leave it alone. Okay, so please enter the water sample temperature. Now it's getting to be too long for one line on mine. Please enter the water sample temperature. So I'm going to change this to right line. And I'm going to break my print statement up into 2 print statements. Please enter the water sample temperature, and apparently I'm misspelling right line. dot
Oh, really?
right. I don't see the problem. I just spelled correctly. All right. Please enter the water sample temperature, and then my second one, console dot, and you don't have to put it on 2.
Oh, really?
4,
Oh,
and then we're going to use a placeholder. And maybe I'll just make it right so that they type, right there. All right, and we want to fill the placeholder in with the day of the week. Well, that is stored in an array called days, and our index value is called x, so days subscript x. Let me try to scroll that over. I may have to zoom out a little bit to get it all. No, I can barely do that. This is inside the loop, inside the do loop in the first region. And that's what your code needs to look like if you're trying to make yours look exactly like mine. But you don't got it, as long as you have the placeholder and the value that you're putting in the placeholder is that string, that element in the array. All right, so use console read line to read the result into the input string. Well, we already have an input string variable already declared, so that's easy. Input string is equal to console.readline. We prompted them for the temperature, now we're letting them type it in. And just like every other time, we're going to use double dot try parse. Try to get the value out. And if it fails, they're going to be asked the question again. That's why it's inside a do loop. Okay, so use double dot try parse to convert input string into input temperature. We love our long variable names. Storing the Boolean return value into the be valid input variable. I hope I declared that. Yeah, I did. Okay, it's up here. Be valid input is equal to false. That's going to be our loop control variable, actually. This could have just as easily been a while loop. Anyways, alrighty, so be valid input. To my mind, prefixing it with a B means that it's a Boolean variable. That's a style of notation called Hungarian, where if it's an integer, you prefix a variable name with an I. And if it's a float, you prefix it with an F. That's an old programming habit. C++ developers. Microsoft came up with that, and so a lot of their code examples use that. I don't see it anywhere else. Be valid input is equal to double dot try parse. We're going to pass our input string in, input string, and we want the results stored out input temperature, like that. So, slightly too long to fit on one page on my screen unless I zoom out slightly. There, like that. Right, be valid input equals double dot try parse, input string, comma, out space input temperature. And is our data valid? Well, be valid input would be set to false if try parse failed, and so we yell at them. Must be a numeric value. Else, we do store the result of input temperature into our temperatures array. I need to refresh my mind. I need to scroll back up and find out what my temperatures array is called. It's called temperatures. How clever. All right? So this is step D. Temperatures subscript x. It's a parallel array for day x. We want a corresponding temperature x is equal to input temperature. Now I seem to see a red error down at the bottom. No, yeah, so I can't wait till we get to that so we can fix it. And the loop just keeps looping while be valid input is false. Eventually they're going to enter a good piece of data. It's going to drop out of the loop. All right, so that's the end of that region. I think I'm going to minimize that region. I'm going to scroll up here, minimize the gather input region, and expand the build results array region. write a loop that will create a string array that is a table like this. Temperature of 16 is freezing, temperature of 300 is boiling, temperature of 88 is liquid. Okay, so what are we doing here? We're iterating through the loop. We're going to check to see if that temperature is less than 32, that means it's freezing, or it's greater than 212, that means it's boiling, and anything else means it's liquid. So we're going to create a string array called results with as many elements as there are in our days array. And we could have just looped through it and we could have printed these results out, as we went, but instead we're going to create this array to hold the results, and then the very last thing we do is going to be to print the contents of the array out. And now fix the loop here to go from 0 to the length of the temperatures array. I'm going to use my loop variable x again. Int x equals 0. Keep running while x is less than temperatures.length. And then plus I. And we could have used any of our arrays here. All of our arrays are of the same length because they're parallel arrays. We could have even created a variable at some point, that indicated the max value of the arrays or the array length. Okay, so we have a water state string. And what we're going to do is we're going to build a string that looks like this. It's going to have the day of the month. It's going to have the words temperature of, and then it's going to have the value, and then it's going to have this variable which indicates whether it's freezing, boiling, or liquid. So we're going to have at least 2 placeholders, maybe 3. So we get to write this one out to ourselves. It's just an if statement. If, I have an error here. My loop control variable is x, and then I typed ++ I there. My mistake. Make that ++ x. All right, so if temperatures subscript x is less than 32, then water state equals, quote, freezing. Else, if, parentheses, temperatures subscript x is greater than 212, we're in America here, we use Fahrenheit, water state is equal to, quote, boiling, end quote. And if neither one of those are true, it's a liquid. Else, water state equals liquid. And I put the semicolon inside the quotes rather than outside it. I'm going to correct that. Now sometimes when I have a whole bunch of if statements lined up like that, I like to format them a little bit differently. Sometimes I do this. But now it's not going to fit on one screen, so maybe I'll undo it. But anyways, like this. That's just me. That's a personal quirk, right? It makes it kind of look like case switch statements. I think I'm going to undo that, especially since it doesn't quite fit on the screen. Well, there we go. Feel like leaving it? Feel like doing that? Great. You don't? Also great. I should have copied it so that I could paste it. There. Okay. Now assign to the output line variable using string.format that matches this. The day and then temperature of the temperature is freezing. So the first placeholder is going to be filled by the days array. The second placeholder is going to be filled by the temperatures array. And the third one is going to have that variable that we just created. So this is going to be probably a long string.format that I'm probably going to break into several statements. So output line, and I sure have been a naughty boy there. I don't know why I made that an uppercase O. when camel case would dictate that that's lowercase o, but I'm not going to change it. I'm just going to roll with it. Output line is equal to string.format. And to give myself extra room for all this stuff, I'm just going to go to the next line right away on my string.format. I'm even going to put a semicolon after the parentheses. All right, so string.format. First thing I need is the day. %0. Colon. Temperature. And we don't have to end real soon. Temperature of placeholder 1 is, and then placeholder 2, which is going to be the state, the freezing, whatever. And so outside of my quote, after the last curly brace, outside of my quote, I'm going to put a comma, and then I'm going to go to the next line, and I'm going to fill in my 3 variables. This is days subscript x, that fills in that one. This is temperatures, subscript x, that fills in that one. And then this is water state. And it's not an array. Take away that semicolon, my mistake. All right. In fact, I have my semicolon and my colon on the next line. I think I'm going to correct that so that it looks kind of like that. All right. Did you have to break it into 3 lines like that? No, if you want one great big long line of code, that's totally okay. And then add that output line to the array of results. Well, our array of results is called results. So the very last thing we do is going to be results subscript x is equal to that output line, capital O output line. I'll be out of here in just a moment. And then we need a for each line to print them all out. So we're going to rush through this because I need to vacate the room. For each string s in results, in parentheses, curly brace, console.writeLine, console.writeLine, that result. All right, that's what we want. I wonder if it's going to work. I still see this red arrow down here. I must have put in too many curly braces or something. Yeah. If you have a curly brace problem at the bottom, fix that. Okay. Give it a run. Temperature for Monday, 78. Temperature for Tuesday, 0. Temperature for Wednesday, whatever, 400. 56. -20. And it tells me, Monday it was liquid, Tuesday it was freezing, Wednesday it was boiling, Thursday it was liquid, and Friday it was freezing. All right. So, it worked on mine. If you can't get it to work on yours, I will upload the notes. You can take a gander there. And welcome to Arrays.